Hello students, welcome to SV Technologies. ER diagrams or ER model. ER diagram. ER diagram is a specialized graphic that illustrates the relationship between entities and database. ER stands for Entity and Relationship Model. It is a high-level data model. It develops conceptual design for the database. The model is used to define the data elements and relationship among them. Here we have given a simple example for ER diagram. Further we are going to discuss about this ER diagram deeply. Student is an entity which is real world object. College is an entity which is real world object. The relationship between the student and college will be study in. In this diagram, student, college are entities as I said. They have some attributes. The property of an entity is called as attribute. That is, the student have ID, name and Aadhaar. These are the properties of a student called as attributes. Here, first we are going to discuss some basic components of ER diagram, also called as basic building blocks of ER diagram: entity, attribute and relationship. Entity. Entity is a real world object. It may be physical or logical existence. It is represented by a rectangle. Suppose we can see here, customer is a real world object which is a person, physical existence, represented by rectangle. In these entities we have physical existence and logical existence. We know that physical existence means we can see and physically we can feel and touch it. That is person. Customer is a person. Example. Logical existence. Logical existence means job, course, concept, etc. We cannot feel it physically. We cannot touch. These are called as logical existence. Here in entities mainly we have two types, that is weak entity and strong entity. The actual entity which is shown in rectangular box is known as strong entity. Weak entity. Weak entity means simply an entity which depends on another entity is known as weak entity. Here in the diagram the weak entity is represented as double rectangle. Okay, weak entity is represented by double rectangle. Entity type. It refers to the category that a particular entity belongs to. For example, a table named student in a university database. We have a university database. In that we have so many tables. In that student table is an entity type. A table named employee in company database. Here also in a company there are so many tables are there in company database. In that employee is an entity type. Here we have to remember one thing. The category of a particular entity in the relation in RDBMS is called the entity type. It is represented by the name of the table and its schema. Here we have taken an example of student entity type. Student entity type means not single student. It is the collection of students or it is a category. Entity set. An entity set is a collection or set of all entities of a particular entity type. Suppose we have taken a student is an entity type in past slide. That student entity types collection is known as entity set at any point of time. The type of all the entities should be the same. Means the collection of all the students from the student table at a particular instance of time is an example of entity set. Otherwise, we can take one more example of employee. The collection of all the employees from the employee table at a particular instance of time is an example of entity set. Here we can see an example of student, and student is an entity. The number of student entities is entity set E1, E2, E3. Entity 1, entity 2 to entity 3. These all are student entities. Here we have to remember one thing. Entity set need not to be disjoint. The collection of all the entities in the relation of RDBMS is called entity set attribute. So simply the property of an entity is known as attribute. Every entity is a real world object. It should have some properties like name, rule number, and age, date of birth, salary, like this. Here, if we take student as an entity, the properties of student entity will have these attributes, that is rule number, name, batch, and age. Here we have so many types of attributes in RDBMS. We can see in next slide. That is composite attribute. Composite attribute means simple attribute which can be divided into subparts further is known as composite attribute. For example, if we take name as an attribute, we can divide that name into first name, middle name, and last name, like this. The attribute which can be divided into subparts is known as composite attribute. We can take another example, address. We can divide into city, state, pin code, and house number. Like this, we can divide an attribute into subparts, then it is called as composite attribute. Next one, simple or atomic attribute. So this is the quite opposite to the composite attribute, which cannot be divided further. Means suppose pin code is an example for simple attribute which cannot be divided again. Suppose student is an entity which has rule number, class, and age. So these rule number, class, and age are we are unable to divide again, like first name, last name, middle name. Single valued attribute. So the attribute which have a single value for a particular item is known as single valued attribute. Suppose if we take a student entity, the gender should be only single valued. It should be either male or female, like this. If a student has rule number, should be single value. Any student should not have two rule numbers, like this. Single valued attribute. Multi-valued attribute. It is exact opposite of single valued attribute. Single valued attribute can have only single value at particular item. Here multi-valued attribute can have more than one value for each attribute. Here example, multi-valued attribute. Attribute having a set of values for single entity is called multi-valued attribute. It is exact opposite of single valued attribute. Single valued attribute have only single value for particular item. Here we can have more than a value. Means suppose if we take a student as an entity, student can have more than one email ID, one mobile number, and more than one hobby, like this. This multi-valued attribute will be represented by double ellipse. Derived attribute or stored attributes. When one attribute value is derived from the other is called a derived attribute. For example, age can be derived from date of birth, where age is the derived attribute, date of birth is the stored attribute. Derived attribute is represented by dashed ellipse. Student is an entity, date of birth and age. Date of birth is an attribute, age is derived attribute which is derived from date of birth. It is represented by dashed ellipse. Key attributes. It is also called as primary key. Key attributes are special type of attributes that act as the primary key for an entity and they can uniquely identify an entity from an entity set. The value that key attribute stores must be unique and non-repetitive. Here we take student is an entity. The student roll number will be unique. It should not be repeated. It is represented by ellipse with the text underlined. Each table must have a key attribute. Okay. Relationship. A relationship is very simple. An association between one or more entity types is known as relationship. Entities take part in the relationship. It is represented by diamond shape. We call it rhombus shape. Okay. For example, a teacher teaches students. Here, teacher and students are entities. Teaching is the or teaches is the relation between the teacher and student. Here we can take another example, student and college. Student is an entity and college is an entity. The relationship between the student and college is studies in. Okay, this is relationship definition. Types of relationship, or we can call it cardinality of relationship. We have mainly three types of relationships or relationship cardinality. That is one-to-one relationship. The second one is one-to-many or many-to-one relationship. The last one is many-to-many relationship. We will discuss about each one briefly. One-to-one relationship. Such a relationship exists between each instance of one entity is related to only one instance of other entity. Means, for example, if there are two entities, person and passport, and each entity will have some attributes, properties we call it, that is person ID, name, age, address. For passport entity, we have attributes passport ID and passport number. For each person can have only one passport, and each passport belongs to only one person. For a person, there should be only one passport. For one passport, it belongs to only one person. No one can have two passports, or no passport belongs to two persons. This is the link. Okay. Next one to many or many to one relationship. Such a relationship exists between each instance of one entity can be related to one or more than one instances of other entity. This relationship is the most common relationship found. A one to many relationship can also be said as a many to one relationship depending upon the way we view it. Here, for example, we take a customer. A customer can have any number of accounts. Suppose if myself I have more than two accounts in my Gmail, like that. If there are two entity type, customer and account, then each customer can have more than one account, but each account is held by only one customer. In this example, we can say that each customer is associated with many accounts, so it is one to many relationship. But if we see in other way, many accounts is associated with one customer, then we can say that it is a many to one relationship. Last one, many to many relationship. Such a relationship exists between each instance of the first entity can be related to one or more entities on one or more than one instances of the second entity, and a single instance of the second entity can be related to one or more than one instances of the first entity. A many to many relationship can be seen as a two one to many relationship which is like a which is linked by a linking table or associate table. The linking table links two tables by having fields which are the primary key of the other two tables. We can understand this with the following example. A customer can buy any number of products, and any number of products can buy by any number of customers. Okay, if there are two entity type, customer and product, then each customer can buy more than one product, and a product can be bought by many different customers, like this. Degree of relationship: the number of different entity set participating in the relationship set is called a degree of relationship. Types: we have mainly four types of degree of relationship: unary relationship, binary relationship, ternary relationship, and N-ary relationship. Unary relationship: it is the relationship between the instances of a single entity type. We can see here. Employee supervise another employee. Same type of entity is going to participate in a relation, is known as unary relationship. Binary relationship: it is the relationship between the instances of two different entity types. Here customer is one type of entity and account is another type of entity. There has is a relationship which is associated with two different type of entities, is known as binary relationship. Ternary relationship: it is the relationship between the instances of three different entity types. Suppose works in is a relationship. In that work, the department and the location and employees, these three entities, three different entities are going to be participated, is known as ternary relationship. N-ary relationship: it is generalized form of a relationship when n number of total entities are participating. Here we can see R is a relationship. In this relationship, there are so many number of entities are going to be participated: teacher, location, class, salary, course, etc. Like this, we can have any number of entities can be participated in a relationship. Finally, we can see a ER diagram of a company or organization. In company, we have an employee or employee entity, and department is also an entity, and project is an also entity, and dependent is an entity. Here, each entity can have the properties called as attributes. Suppose if we take employee is an entity, employee can have ID, name, address, date of birth, and employee can have date of joining and his gender, male or female. And as well as department can have some properties like department number, name, location. The employee works in some department. Here works in is the relationship between the employee and department. Employee should work in a department, and every department has few projects. Means the relationship between the department and project is has. Here the employee is dependent of dependent entity. This is, and employee can be a manager to department. So manager is also a relationship, and the employee can work how many hours on a project. Here works on hours. Employee should work few hours on that project, means works on hours is the relationship. Like this, we have an entity relationship diagram for a company or organization. Okay, thank you for being here. For more videos like this, please do subscribe to my channel SV Technology. This is Mahesh signing off.